Welcome to part 4 of our COVID analysis. In the last video, we had created this chart that compared the relationship between the number of deaths and the number of cases, both current cases and those that were tracked 2 weeks ago versus 1 week ago. So now, and we see that there definitely is a relationship here. And although this gray line seems to fit best the 1 week ago with the number of deaths, I showed you in the last video by changing this scale that it's really subject to change. So a correlation is really whether these lines are sloping the same, whether this line, or this line could be a predictor of the blue line. So let's compute a correlation just like we did previously in the semester with our baseball data or our Titanic data. So I'm going to move my chart down a little bit and gain a little space here. So I'm going to use the Correll function again to compare. I want to have all three ranges have the same number of rows, so in order to do kind of an apples to apples comparison. So I'm going to I'm just going to go over here and type my first function equals Correll, and I'm going to select the range for the number of deaths, and I'm going to put a comma in order to select the second range, which is our current number of cases per date. And I'm going to hit enter to get my result. And you can see there's a very strong correlation. I don't want this as a percentage because it's not technically a percent. Just going to have this a number. Let's put 3 decimal points in there. Okay, so let me add some labels here. I'm just going to type confirmed cases over here. And then we'll do the same thing here where we select our data from the number of deaths, put in a comma, and then select the number. Whoops, that's the wrong. I'm sorry, I'm going to select the number of deaths and insert a comma and select the number of cases from 1 week ago. And you see that once again, there's a very strong relationship, 99.7%. It's not technically a percent, so I'm going to change the format again. Confirm, or I'm going to call this cases minus 1 week for make sure I keep up with my labels. Cases minus 2 weeks. And I'll enter the Correll function again. Select the range of data that has my deaths and the range of data that has the number of cases from 2 weeks prior. And you have a very, very similar result. So all three are really excellent predictors. Trying to put them all in the same format. Okay, so it really honestly doesn't matter which one of these the strongest relationship is minus 1 week, but It's really just a fraction of a percent, 1/1000th. So I really think the cases minus 2 weeks is the most interesting just because it provides the most predictive power. So you can infer from this. So if I have currently, as of April 29th, I have, what happened to my dates? Went away, but I have this number of current cases. Um, how many deaths will I have in 2 weeks? So the nice thing about this being such a strong number, strong correlation, is it might help us predict how many deaths there would be in 2 weeks. So I'm just going to move this data out of the way. I'm going to copy this and move it down below here. And I'm going to paste the values. I lost my formatting, but I can get that back quickly, comma, and increase the decimal. And while we're here, let's just make a little bit of a heading out of it. I'm not going to make a chart out of this because they're so close together, it wouldn't really, visually, it wouldn't be very interesting. So I'm just going to merge and center, and I'm just going to put a little heading in here. Correlation with number of deaths, and just going to copy that down and put Ontario COVID. Sorry, I can't type. And just a little bit of simple formatting. Do a little bolding. Maybe put a border around all of it, and that'll be good enough to show on the website. Okay, so we've computed the correlation. Now let's see one more statistic. I've already copied this down, so I'm going to delete that. I'm interested in seeing the percentage of people that die for each of these. So what does that mean? 6 out of 503, or 6 out of 34 if we go back to 2 weeks ago. So let's compute a percentage here. So I'm just going to take the number of deaths and I'm going to divide it by the number of cases. And I'll scroll down to auto fill that range. And you can see the trend line between the current number of cases and the number of deaths is increasing. However, if you look from, let's do the same thing for the number of deaths and the number of cases a week ago. And I'm going to put that into percent format with 1 decimal. And I'll do the same thing one more time here. Number of deaths divided by number of cases 2 weeks ago. And you can see originally like 17% of the people were dying. But one encouraging thing is that it's starting to flatten a little bit. So this could be worth making a chart by itself. So you could select this data and insert a line chart. I would want to bring back my dates. I don't know how those got deleted, but I could go back to my previous data set. And I could autofill these dates just to get those back on the chart. And I could select these columns and do a line chart just as I did before here with the percentage of death to show the trend line. So I could select this data and, whoops, select the 23rd through the 29th. And I would also hold my control button down and select these ranges and insert a line chart. And I'm not going to do it on the video, but you would want to do similar formatting where you label these three series and showed how the death rate is increasing or decreasing relative to the number of cases. So you would have a chart title here with something like deaths per case, and then you would label series 1 as number of confirmed cases, cases minus 1 week, cases minus 2 weeks. And then lastly, one thing you might comment on is how, because we have such a strong correlation here, especially with 2 weeks, you might say that we currently have 16,978 cases. Based on our past track record, you could try and say, how is this data trending? It's sort of flattening off at 13 something percent, but it's going down slightly. So I don't know how you think it would be in 2 weeks. This is what public health people try to predict, and it's inexact science, but you might say, let's say 12% would be the number 2 weeks from now. And so you might predict that 12% of this number would be the number of deaths in 2 weeks. So equals C53, which is the current number of cases as of the 29th, times 12%. And you could predict that this number of 1153 would go up to 2,037 by the middle of May. Now that's not an exact science, and I wouldn't put too much stock in it, but that's something you might include in your analysis, and it might be interesting to see how correct it is. So we have kind of a messy workbook. I mentioned that we're not going to worry too much about formatting here, but so we have the deaths by date, confirmed cases by date. We don't really need to publish anything with the original data set, but we have cases versus deaths. And then we have a lot of information on this correlation sheet where we show the deaths versus the number of weeks ago. We have a correlation chart that we can publish. And then once formatted, we can also show this chart that shows the trends of the percentage of deaths per case. And then lastly, you could put in a blurb where you maybe just a text sentence about predicted number of cases in 2 weeks. So that concludes this video. I think we're done using our Excel analysis. In the last video, we're going to be showing how to move our data just by simply doing screenshots over to the website. So thank you, and I'll see you in the next video.